When the James Webb Space Telescope first turned its golden mirrors toward the deep void, no one truly knew what it would find. Scientists had spent decades imagining what the universe looked like just after the Big Bang, that mysterious dawn when the first stars ignited and the darkness began to glow for the very first time. They believed they had a clear picture of how it all began, a slow, patient process where gravity, gas, and time gently sculpted the first galaxies over hundreds of millions of years. But when Webb began sending back its first images, that comforting picture shattered. What it saw was something no one expected, something that by every law of cosmology shouldn't exist. Because hidden in the faint red light of the early cosmos were over 300 galaxies, ancient, enormous, blazing with energy, all existing less than 500 million years after the Big Bang. To put that into perspective, if the entire history of the universe were condensed into a single year, these galaxies appeared in just the first few days after creation. According to everything we thought we knew, there simply shouldn't have been enough time for such structures to exist. Yet there they were, like islands of light floating in a sea of cosmic darkness, proof that the universe was far more advanced at its beginning than anyone had dared to imagine. For decades, scientists had assumed that the earliest galaxies were tiny and chaotic, little clusters of stars forming out of primordial hydrogen. They expected Webb to find faint, shapeless smudges barely worthy of the name galaxy. Instead, what appeared on Webb's sensors were objects so bright and massive that some rivaled the Milky Way in size. These galaxies had structure, cohesion, and most shockingly, maturity. The light captured by Webb had been traveling toward us for over 13 billion years, crossing nearly the entire age of the universe. When those photons finally reached Webb's mirrors, they carried within them a message from the ancient past, one that rewrote the story of everything we thought we knew about the cosmos. Astronomers stared at the data in disbelief. The universe, in its infancy, wasn't supposed to look like this. In those early ages, matter should still have been gathering itself, cooling and condensing into the first stars. Yet Webb's images showed fully formed galaxies, some packed with billions of suns, shining brightly when the cosmos was less than a billion years old. That meant that somehow, in a fraction of the time expected, these galaxies had formed, matured, and lit up the early universe with a brilliance that seemed impossible. It wasn't just one anomaly, it was hundreds of them, over 300 separate galaxies appearing in that impossibly early epoch. Their redshift values, a measure of how far their light has been stretched by the expansion of the universe, placed them at the very edge of time itself. Every data point, every spectral analysis seemed to scream the same thing. These galaxies are too old, too big, and too bright for their age. Something about the universe's timeline didn't add up. At first, scientists questioned the data. Could there be an error in the calibration? Was the redshift measurement wrong? Could these objects be something else, perhaps quasars, or young galaxies distorted by gravitational lensing from massive clusters between them and us? They rechecked the observations again and again. The data held firm. Webb's instruments, designed to see deeper into the infrared spectrum than any telescope before, were functioning perfectly. There was no mistake. These galaxies were real. They existed when they shouldn't have. That realization sent ripples through the entire scientific community. Cosmology, the story of how everything came to be, suddenly felt like a puzzle with missing pieces. The established model, the one that explained how matter slowly clumped together under gravity to form stars, then galaxies, then clusters, was suddenly inadequate. The early universe, it seemed, was far more efficient and creative than anyone had imagined. The discovery forced scientists to ask a profound question: how could the universe create so much so fast? According to our best theories, There simply wasn't enough time for gravity alone to build galaxies of such mass and complexity so soon after the Big Bang. Something fundamental about our understanding of physics, star formation, or the evolution of structure might be incomplete. Perhaps the laws that governed the early cosmos were slightly different. Or maybe the initial conditions of the universe, the density of matter, the role of dark matter, the behavior of cosmic inflation, weren't exactly what we thought they were. But beyond the mathematics and data models, there was something deeply human about this discovery. It reminded us of how little we truly know. For centuries, every time humanity built a better instrument to see deeper into the universe, we found not confirmation of what we knew, but surprise, mystery, wonder, and contradiction. Webb's 300 galaxies became the newest reminder of that eternal truth. The cosmos does not follow our expectations. It does not fit neatly into the boxes we build for it. It stretches the imagination, defies logic, and invites us to expand our understanding again and again. Each of those galaxies Webb captured represents an entire cosmic city, billions of stars, countless planets, and perhaps even the raw ingredients for life. To think that they existed so soon after the birth of everything is staggering. It means that the universe wasted no time in creating complexity. The moment it could, it began to form light, structure, and maybe even the seeds of life itself. In that sense, the universe seems almost impatient, a cosmic artist painting galaxies before the canvas of time had even dried. And yet, as scientists examined these galaxies more closely, the mystery deepened. Many of them appeared too luminous to be explained by normal star formation. Some shone with the intensity of entire clusters, suggesting they might contain enormous black holes or be powered by unknown energetic processes. Others showed signs of mature chemical composition, heavier elements like carbon and oxygen that should have taken generations of stars to produce. How could these galaxies have such metals so soon after creation? The first stars, known as population Roman 3 stars, were thought to be pure hydrogen and helium with no heavier elements. For metals to appear, those stars needed to live, die, and explode in supernova, a process that takes hundreds of millions of years. Yet these galaxies already contained them. That single fact was like a fingerprint left by something unexplainable. It meant that somehow star formation and death must have occurred at a furious pace, far faster than our models allowed. The universe, in its first moments, was not empty and slow. It was dynamic, restless, and astonishingly productive. Some astronomers began to call these galaxies the cosmic rebels, while others gave them a more dramatic nickname, the impossible galaxies. Because their very existence breaks the rules of known cosmology, to explain them, we may need to rethink not just when galaxies formed, but how. Perhaps dark matter, that mysterious invisible substance that makes up most of the universe, played a more active role than we realized, rapidly pulling matter together into dense halos that could ignite star formation earlier than expected. Or maybe the physics of the early universe allowed gas to cool and collapse more efficiently, skipping steps we once thought were necessary. Whatever the explanation, one thing was certain: this discovery opened a new chapter in the story of the cosmos. The James Webb Telescope had delivered what it was built for, not just data, but revolution. It forced humanity to confront the limits of its knowledge and to see the universe not as a solved equation, but as a living mystery still unfolding. In the grand scheme of things, these galaxies are not just ancient objects in the sky. They are echoes of creation, light that has traveled across 13 billion years of cosmic history to reach us. When you look at Webb's images, you're not just seeing distant galaxies, you're seeing time itself. Each pixel of light is a message from the past, a photon born before our solar system, before our planet, before life itself. And in those messages, the universe seems to whisper something profound: you do not yet know me. For humanity, this is both humbling and exhilarating. It means that the universe is still full of firsts, first discoveries, first mysteries, first glimpses into realities beyond our imagination. Every time we think we've reached the edge, we realize the edge has moved. These 300 galaxies, glowing in the ancient darkness, prove that even the earliest moments of existence were filled with wonder. Astronomers now work tirelessly to understand them. New observations are planned, data is being analyzed, and theories are being rewritten. Some researchers believe that Webb has only scratched the surface, that even older, fainter galaxies lie just beyond its current limits, waiting to be revealed. If that's true, then what we've seen so far might only be the beginning of a much deeper cosmic story. But even if we never fully solve the mystery of how these galaxies came to be so quickly, their discovery has already achieved something far greater. It has reignited our sense of cosmic curiosity. It has reminded the world that science is not about certainty, it's about exploration. It's about daring to look into the unknown and accept that the answers might surprise us. The James Webb Telescope was built as a successor to Hubble, but it has become something even more profound, a time machine. It is humanity's eye into eternity, showing us that the universe was not born quietly, but in a blaze of light and order that came far sooner than anyone dared to believe. The 300 galaxies that shouldn't exist are not mistakes or anomalies. They are the universe's way of telling us to look deeper, to question harder, to wonder more. They are the proof that creation itself is bigger than our theories, wilder than our expectations, and more beautiful than our minds can yet comprehend. And as Webb continues to explore the deep cosmos, somewhere out there in the vast silent darkness, more impossible discoveries await, waiting to challenge us, humble us, and remind us that we are still children staring up at the infinite sky, asking how it all began, because in the end, that's what makes these galaxies so powerful. Not just their existence, but what they represent, the universe's unending ability to surprise the beings within it. The cosmos, even after 8 billion years, still holds secrets it's not yet ready to reveal, and that is the greatest wonder of all. When the first galaxies appeared on the James Webb Space Telescope's deep field images, the world saw beauty, a tapestry of glowing lights stretched across infinite blackness. But for scientists, those glowing lights carried something far more profound: contradiction. Those ancient galaxies, some burning bright just a few 100 million years after the Big Bang, didn't just represent new discoveries, they represented broken timelines. For decades, cosmologists had drawn the story of the universe with precision and confidence. There was the Big Bang, a violent birth of energy and expansion. There was cooling, recombination, the formation of neutral hydrogen, and then the slow ignition of the first stars, hundreds of millions of years later. That timeline, etched into textbooks and theories, had survived generations of testing. But when Webb looked deeper than any human eye had ever seen, that timeline began to crumble. The light Webb captured was ancient beyond imagination. It came from a time when the universe was only 2% of its current age, a mere infant in cosmic terms. According to our understanding, galaxies of that era should have been small, faint, and primitive, their stars newly born, their shapes irregular and chaotic. But Webb's images revealed something that defied that logic: galaxies that were large, well-structured, and astonishingly bright. Their existence implied that star formation and galactic evolution had begun much earlier than the accepted timeline allowed. In a single sweep of its infrared gaze, Webb had shifted the cosmic calendar backward by hundreds of millions of years. For generations, scientists believed the early universe had followed a predictable rhythm. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form, the era known as recombination. After that, it plunged into a period called the Cosmic Dark Ages, a time before the first stars ignited. According to the best models, it took roughly 400 to 500 million years before gravity slowly pulled together the first dense clouds of hydrogen that could collapse into stars. The first galaxies were expected to appear around 600 million years after the Big Bang, faint and tiny, slowly gathering mass over billions of years. That was the cosmic timeline, the carefully constructed script that explained how something as vast as the modern universe emerged from a near-uniform fog. But the James Webb Telescope doesn't read from our script. Its mirrors, cooled to near absolute zero, stare into the deep infrared, the light stretched by cosmic expansion to wavelengths invisible to human eyes. In those wavelengths, Webb doesn't just see stars and galaxies, it sees time itself, bent and elongated by the universe's own growth. What it found in those depths was a universe in full bloom far earlier than anyone had expected, galaxies shining bright just 300 to 400 million years after the Big Bang. Massive spirals with mature stars, dense clusters with organized structure. It was as if Webb had opened a door to the past and found civilization already thriving when we thought existence was still learning to crawl. Scientists reacted with both awe and disbelief. The data forced them to re-examine one of the most fundamental questions in cosmology: how fast can the universe build itself? The discovery implied that galaxies didn't take hundreds of millions of years to grow. Instead, they must have formed rapidly, almost explosively, in the cosmic dawn. If true, this meant that gravity, dark matter, and gas dynamics worked together with astonishing efficiency, condensing matter into luminous structures in record time. It also meant that our models of the early universe, painstakingly refined for decades, were incomplete. The timeline wasn't slow and gentle, it was fierce, accelerated, and vibrant from the very beginning. To understand why this shattered expectations, you have to imagine the scale of cosmic creation. Galaxies like the Milky Way contain hundreds of billions of stars. Each of those stars forms from a collapsing cloud of gas, a process that can take millions of years. For such massive systems to exist only a few 100 million years after the Big Bang, that process must have occurred in overdrive. Either the first stars formed almost instantly, or the universe itself provided conditions that allowed matter to collapse and ignite far faster than any simulation had predicted. Neither explanation fits comfortably within current theories. It's as though the universe jumped ahead in time, skipping evolutionary steps we thought were essential. This discovery doesn't just challenge when galaxies formed, it challenges how we think the universe evolved. If galaxies appeared earlier, then the cosmic web, the vast network of filaments connecting all matter, must have taken shape faster too. The dark matter halos that serve as the gravitational skeleton of galaxies must have coalesced sooner and more efficiently. The chemistry of the early cosmos, the enrichment of elements through stellar life cycles, even the nature of dark energy and cosmic expansion, all of these might need to be reconsidered. The timeline wasn't just off by a little. It was fundamentally rewritten. To visualize the scale of this upheaval, imagine history itself being compressed. Imagine if archaeologists discovered a fully built city complete with skyscrapers and highways in a layer of Earth's crust dated to the age of dinosaurs. That's what the James Webb Telescope has done to cosmology. It's as if we've found civilization at the dawn of creation, and the story we've been telling about how everything grew from nothing now feels incomplete. This isn't the first time humanity has had to rewrite its cosmic story. When Galileo pointed his telescope to the heavens, he found moons orbiting Jupiter, disproving the notion that everything revolved around Earth. When Edwin Hubble measured galaxies receding from us, he proved the universe was expanding. Each time, discovery demanded humility. And now, with Webb, that cycle continues. The cosmic timeline, once drawn in confident ink, must now be sketched anew in pencil, flexible, open to change. The implications stretch beyond astronomy. The universe is not merely older in appearance. It is more alive, more dynamic, and more unpredictable than we've dared to believe. For scientists, that means confronting the possibility that their most trusted equations, the ones describing how matter and energy behave at large scales, may not tell the whole story. For philosophers and dreamers, it means realizing that creation was never a quiet process. It was an eruption of beauty, an explosion of complexity that began almost as soon as time itself began ticking. The cosmic timeline we once cherished was built on observation, simulation, and the limits of human technology. The Hubble Space Telescope gave us a glimpse into the early universe, but its vision was confined by the visible spectrum. It could see far, but not far enough. Infrared light, the key to viewing the most ancient stars and galaxies, was beyond its reach. Webb, however, was designed to capture that elusive light, the stretched whispers of the universe's earliest moments. And when it did, it revealed a universe that had already written chapters we never knew existed. Every one of those 300 galaxies tells part of that hidden chapter. Each represents a snapshot of a universe that built itself at lightning speed. Some of these galaxies are compact and intensely bright, suggesting rapid star formation. Others show surprisingly ordered shapes, hinting at early gravitational stability. Together, they speak of a cosmos that wasted no time in finding its rhythm. The age of chaos and darkness may have been far shorter than we imagined. Instead of a long, slow dawn, the universe may have erupted into brilliance almost immediately after its birth. This accelerated timeline also reshapes how we think about reionization, the epoch when the first stars and galaxies reionized the hydrogen that filled the cosmos, allowing light to travel freely. Again, previously, scientists thought this process took place between 400 and 800 million years after the Big Bang. But if galaxies existed earlier, then reionization must have started much sooner. That means the first stars, the mythical population Roman 3 stars, might have appeared within just 100 million years of creation. These stars, massive and short-lived, would have burned with fierce intensity, creating the first heavy elements and seeding the universe for later generations of stars and planets. Webb's discovery implies that the cosmic night ended much earlier than we believed, the light of creation breaking through sooner, faster, brighter. And yet, despite the thrill of discovery, there is unease among scientists. The earlier timeline threatens the stability of the entire cosmological model. If the early universe produced galaxies this quickly, it could mean that dark matter behaves differently than we think. It could mean that the rate of cosmic expansion driven by dark energy varied in ways not yet understood. Some even suggest it might point to new physics, phenomena beyond the standard model, something fundamental we've missed about how matter and energy interact at the dawn of time. In that sense, the shattering of the timeline is not just a problem of age, it's a problem of understanding. But perhaps that's the beauty of it. The timeline was never meant to be final. The universe has always been one step ahead of us, revealing just enough to make us question, to make us look deeper. Webb's discoveries are a continuation of that cosmic dialogue, the universe speaking and humanity listening, rewriting, learning. We thought we understood the rhythm of creation, but the melody turned out to be faster, richer, more intricate than we ever imagined. For the ordinary person looking at those distant galaxies, this may sound abstract, numbers, redshifts, timelines. But there's a profoundly human message hidden in it. The universe is not static. It evolves in bursts, in leaps of wonder. It is alive with creativity from its very first moments, and so are we. We, too, are born from that same cosmic fire, products of an existence that refuses to move slowly, that strives always toward light and complexity. Those early galaxies, burning in defiance of time itself, are mirrors of that spirit. They are proof that creation, whether cosmic or human, doesn't wait for permission. It happens where and when it must. Even now, scientists continue to debate the data. Some argue the galaxy's distances could be miscalculated, that their apparent brightness might come from gravitational lensing, where massive objects bend and magnify light. Others hold firm that the galaxies are genuine, that they are exactly as old and massive as Webb suggests. The truth may take years to confirm, but regardless of the final answer, the cosmic timeline has already changed. Because once you've seen something that shouldn't exist, you can never see the universe the same way again. Each discovery Webb makes is another crack in the wall of certainty, another invitation to wonder. The timeline that has shattered will eventually settle into a new one that will inevitably be shattered again someday. That's the nature of exploration. The universe is not a solved equation. It's an unfolding poem, and we are only beginning to read its first lines. And perhaps that's what makes this moment so powerful. The realization that our universe, once thought to grow slowly and predictably, may have erupted into brilliance almost instantly after its birth, is not just a scientific revelation, it's a spiritual one. It tells us that creation is impatient, that existence itself is driven by an unrelenting desire to evolve, to express, to illuminate. Those first galaxies were not mistakes. They were the universe's first art, painted quickly and boldly across the canvas of space-time. When James Webb looked back to the beginning, it didn't just show us light. It showed us speed, energy, and the fierce creativity of a cosmos that refuses to wait. The cosmic timeline we thought was steady and slow has been shattered, replaced by something more alive, more unpredictable, and infinitely more beautiful. And somewhere out there, beyond even Webb's reach, the universe continues to surprise itself, writing its story faster than any of us could ever read it. When humanity first dreamed of seeing the beginning of everything, it built instruments to stretch our vision farther than our eyes could reach. We built the Hubble Space Telescope, and for decades it gave us breathtaking glimpses into the deep universe, swirling galaxies, supernova, nebulae glowing like cosmic fire. But even Hubble had limits. It could see the visible light and part of the ultraviolet spectrum, but the earliest light of the cosmos had been stretched by time itself, stretched into wavelengths Hubble could not see. To reach the true dawn of creation, we would need a new kind of eye, one that could see through the invisible, one that could peer into the infrared where the echoes of the Big Bang still shimmered. Faintly, that eye was the James Webb Space Telescope. The universe, as it expands, pulls light apart. Every photon traveling through space is stretched by the expansion of the cosmos, its wavelength lengthening over billions of years. This process, called redshift, turns once blue or white starlight into infrared radiation, light too long for human eyes to detect. The farther away an object is, the greater its redshift. That means that the earliest galaxies, the first stars that ever formed, no longer glow in visible light. Their light has been dragged deep into the infrared. So, to see them, we needed an instrument that could see where our eyes, and even Hubble's, could not. James Webb was built for exactly that. Its design was unlike any telescope before it, not a single mirror, but 18 hexagonal segments, coated in gold to reflect the faintest traces of infrared light. Its sunshield, as large as a tennis court, protects it from the heat of the sun, the earth, and even its own instruments. Everything about Webb was built to be cold, silent, and impossibly precise. Its sensors operate near absolute zero, so they can detect the faintest warmth of light that has traveled for billions of years. When it was launched in December 2021, it was more than just a machine. It was a time machine, one that could show us the universe as it existed long before the Earth was born. To understand the power of Webb's vision, imagine standing in a fog so thick you can barely see your hand. Visible light cannot penetrate it. It scatters and fades, but infrared light passes through. That's what makes Webb so extraordinary. The early universe was filled with gas and dust, the leftovers of creation, dense and opaque to visible light. For centuries, this cosmic fog hid the first galaxies from view. But in infrared, Webb can see through that veil. It can capture the light of stars that formed in the first few 100 million years after the Big Bang, light that has been traveling toward us since, before the Milky Way existed. When Webb opened its mirrors to the universe and began collecting its first images, the difference was staggering. The first deep field, a small patch of sky no larger than a grain of sand held at arm's length, revealed thousands of galaxies, some so distant their light had taken over 13 billion years to reach us. Where Hubble had seen faint smudges, Webb saw detail, spirals, clusters, arcs of light bent by gravity itself. In every corner of that single image, the story of the cosmos unfolded, written in ancient light. Infrared vision does more than show us distant galaxies. It shows us the past, because light travels at a finite speed. Every time we look at something far away, we're looking back in time. When we look at the moon, we see it as it was 1 second ago. When we look at the sun, we see it as it was 8 minutes ago. When Webb looks into deep space, it looks billions of years into the past. It sees galaxies as they were when the universe was young, when the first stars were still forming, when everything we know was just beginning. That's why Webb is often described as a cosmic time machine. It doesn't just see distance, it sees history. But the power of Webb's infrared vision lies not only in distance, it lies in clarity. The early universe is not a quiet place. It's filled with cosmic dust, the ashes of ancient stars, the building blocks of planets, the shrouds of new suns being born. In visible light, dust hides everything behind it, like smoke covering a flame, but in infrared, that dust becomes translucent. Webb can see the stars being born inside thick clouds of gas, the formation of planetary systems, the collisions of galaxies birthing new worlds. It doesn't just show us where we came from, it shows us the processes that continue to shape everything. One of Webb's earliest triumphs was its ability to see into the heart of stellar nurseries, places like the Carina Nebula and the Pillars of Creation. Hubble had captured those regions in visible light, showing tall towers of gas lit by young stars. Webb looked deeper and revealed the hidden stars still forming within those clouds, glowing faintly in infrared. It was as if we had been watching a shadow play for decades, and suddenly the curtain was lifted. We saw the actors, the young suns, the swirling disks of gas that might one day become planets. We were no longer just seeing the surface of the universe, we were peering into its womb. Now imagine applying that same power to the earliest epochs of existence. When Webb turned toward the deep sky, its infrared eyes caught light that left its source when the universe was only a few 100 million years old. That light had been stretched by time itself, its wavelength elongated by the expansion of space. To Webb's instruments, that faint warmth was readable, measurable, alive. And in those measurements, scientists found galaxies that defied everything we knew. Infrared light carries stories that visible light cannot tell. It reveals temperature, composition, and distance. Webb spectrographs can separate that light into its component wavelengths, revealing the fingerprints of elements: hydrogen, helium, oxygen, carbon, the ingredients of stars and life. By studying those fingerprints, astronomers can determine how old a galaxy is, how fast it's moving, and what it's made of. And through those measurements, Webb discovered something astonishing. Even the earliest galaxies contained heavier elements, meaning that generations of stars had already lived and died before them. That discovery shook cosmology because it implied that the first stars had formed, burned, and exploded far faster than theory allowed. But none of this would be possible without Webb's infrared eyes. Hubble saw beauty, but Webb sees truth, the hidden architecture beneath the light. It shows us galaxies in the act of forming, black holes feeding in the centers of ancient clusters, and clouds of gas collapsing into stars. It shows us the bones of the cosmos, not just its skin. The further Webb looks, the older the light becomes, until eventually it reaches the edge of the observable universe, the moment when darkness first gave way to light. The technology that makes this possible is as miraculous as the science itself. Webb orbits the Sun 1,000,000 miles from Earth, far beyond the Moon, in a position called Lagrange point 2. From there, it maintains a stable orbit, shielded from the heat and glare of our planet. Its sunshield blocks radiation, keeping its instruments cold enough to detect the faintest whispers of heat from the early universe. Each of its gold-coated mirrors is polished with such precision that if you scaled one up to the size of the Earth, the imperfections would be smaller than a single human hair. Every photon of infrared light that strikes those mirrors is focused, measured, and translated into data that becomes an image, a window into the dawn of time. It's easy to think of Webb's achievements as technological triumphs, but at their heart, they're human triumphs, the culmination of decades of curiosity and courage. Thousands of engineers, scientists, and dreamers worked together to build an instrument capable of seeing what no one had ever seen. They knew it might fail. They knew a single error could doom the mission, yet they built it anyway, because the need to understand who we are and where we came from is stronger than fear. And when Webb finally unfolded in space, when its mirrors aligned and its instruments came to life, humanity crossed a threshold. We were no longer blind to our beginnings. The first images from Webb were not just pictures, they were revelations. Galaxies that had been invisible now glowed in golden red light. Structures we had never seen appeared, arcs of galaxies stretched by gravity, clusters colliding, nebulae carved by starlight. And among them, those ancient galaxies that shouldn't exist, 300 of them, blazing where the universe was supposed to be dark. Webb's infrared vision didn't just confirm what we thought, it contradicted it. It revealed a universe that formed faster, shined brighter, and evolved sooner than we had believed possible. Every pixel of those images carries the weight of time. Each one is a tiny echo from an age when the universe was young. When you look at them, you are literally seeing back in time. The light entering Webb's instruments left its source billions of years ago and has been traveling ever since. In a very real sense, Webb is not looking into space. It's looking into history, into memory, into the cosmic past that gave birth to everything. Infrared vision also reveals motion. By studying the redshift of galaxies, Webb can measure how fast they are moving away from us, helping refine our understanding of cosmic expansion. And the deeper it looks, the more it tells us about how the universe has evolved, how small, dense pockets of gas became vast spirals, how collisions forged larger structures, how gravity sculpted the fabric of space itself. In every frame, Webb captures not a static universe, but one in motion, expanding, changing, alive. But beyond the science, there is poetry in Webb's vision. It is as if the telescope's golden mirrors do not just reflect light, but human longing, our endless desire to know. For all our equations and measurements, what drives us to build such instruments is wonder, the need to see, to understand, to reach for the unknown. Webb's infrared gaze is, in a sense, our collective gaze, humanity looking back at its own beginnings, tracing the lineage of light that eventually led to us. When you think about it, every human being is connected to that ancient infrared glow. The atoms in our bodies, the carbon, the oxygen, the iron, were forged in stars like those Webb observes. The light it captures is not just distant, it's ancestral. It's the story of how the cosmos made itself capable of consciousness, how hydrogen became humanity. And when Webb peers into the deep past, it is, in a way, looking at the first chapters of our own existence. As Webb continues its mission, it will keep refining its view, seeing further, clearer, deeper. It will peer at exoplanet atmospheres, searching for signs of life. It will study black holes at the centers of ancient galaxies, revealing how they grew. It will map the evolution of cosmic structure from the first spark of starlight to the vast universe we know today. Every discovery will add another layer to our understanding, another verse to the song of creation. The power of Webb's infrared vision is not only in what it reveals, but in what it represents, our refusal to accept the limits of perception. We built a machine to see what was once invisible, and in doing so, we discovered that the universe is more complex, more beautiful, and more alive than we ever imagined. Infrared light, invisible to the eye but radiant to the soul of science, has shown us that even the darkness of space is filled with light we simply hadn't learned to see. And perhaps that is the lesson hidden within Webb's gaze. The universe is not silent or cold. It is speaking, constantly, in wavelengths we are only now beginning to understand. It tells us that even in the deepest darkness, light endures, stretched, softened, but never lost. The James Webb Space Telescope is humanity's proof of that truth. It has taught us that the past is not gone, it's still shining, waiting for eyes brave enough to find it. Somewhere, deep in the infrared glow, lie galaxies still unseen, stars still whispering their light across the eons. Webb will find them. And when it does, we will see further not just into space, but into ourselves, into the boundless curiosity that defines what it means to be human, standing in the dark, reaching for the first light. When the James Webb Space Telescope began sending back its first data, astronomers expected to see beauty, yes, glowing galaxies, intricate star nurseries, and the delicate fabric of space, stretched by gravity, but what they didn't expect was confusion. The images Webb sent back were more than beautiful, they were impossible. They showed something that should not have been there, galaxies so massive, so structured, and so bright that they defied everything our current models of the universe predicted. What Webb revealed wasn't just light from the early cosmos. It was a challenge to the very foundation of modern cosmology. For decades, cosmologists have worked within a framework known as the lambda cold dark matter model, or lambdictum. It's our best map of the universe's evolution, describing how everything, from galaxies to galaxy clusters, formed after the Big Bang. According to this model, the early universe was a hot, dense plasma that gradually cooled, allowing simple atoms to form about 380 years after the Big Bang. After that came the Dark Ages, a long stretch of time before the first stars ignited. It was only hundreds of millions of years later that the first galaxies began to emerge, small and primitive, faintly glowing islands of newly born stars surrounded by darkness. But Webb saw something entirely different. It looked deeper than any telescope before it back to a time less than 500 million years after the Big Bang, and found galaxies that looked surprisingly mature. These weren't small, dim, chaotic clouds of gas. They were large, organized, and bursting with light. Some had the mass of the Milky Way, even though, by all logic, There hadn't been enough time for them to form. Imagine looking at a nursery expecting to see newborns and finding fully grown adults instead. That was the shock scientists felt. Galaxies that shouldn't exist, shining where theory said only darkness should reign. In total, Webb identified around 300 of these ancient, massive galaxies, each one rewriting our understanding of the cosmic timeline. To grasp the scale of this discovery, consider how galaxies are thought to grow. In the Standard Model, tiny fluctuations in the early universe, slight differences in density, gradually attract matter through gravity. Over hundreds of millions of years, those clumps of matter form stars, which then gather into small protogalaxies. Those protogalaxies merge, collide, and grow into larger structures. It's a slow, steady, evolutionary process. But Webb's discoveries suggested that this process might have happened far faster than anyone thought possible. Some of the galaxies Webb found existed just 300 to 400 million years after the Big Bang. In cosmic terms, that's like discovering skyscrapers in a city that's only a few days old. They had billions of stars and were already enriched with heavier elements, elements that could only have been forged in multiple generations of stars that had already lived and died. That meant star formation must have been happening at a breakneck pace almost immediately after the universe began. It's as if the universe skipped its childhood. The first galaxies weren't fragile, flickering sparks. They were blazing furnaces of creation. This defied everything we thought we knew about how long it takes for matter to organize itself on such scales. To many cosmologists, Webb's discovery wasn't just unexpected, it was unsettling. Because if these galaxies really existed so early, it could mean that the universe evolved differently than we've always believed. It could mean that the physics underlying our cosmological models needs revision. Some scientists even began to whisper what was once unthinkable, that maybe the Big Bang model itself needed re-examining. Now, that doesn't mean the Big Bang didn't happen, but it does suggest that our understanding of what came after might be incomplete. Perhaps the universe expanded and cooled faster than we thought, perhaps matter clumped together more efficiently, or perhaps the mysterious dark matter that fills most of the cosmos played a bigger role in early galaxy formation than anyone realized. Others proposed even bolder ideas. Maybe the early universe was simply denser, richer in star-forming material. Maybe cosmic inflation, that rapid expansion right after the Big Bang, left behind structures that seeded galaxies sooner than expected. Or maybe something fundamental about the laws of physics, like gravity itself, behaves differently under extreme conditions. But before rewriting the textbooks, astronomers had to rule out simpler explanations. Could these impossible galaxies be optical illusions, the result of gravitational lensing, where massive objects bend light and make distant galaxies look brighter or larger than they are? Could Webb's instruments be misinterpreting redshift, confusing closer, smaller galaxies for ancient, massive ones? Teams across the world began analyzing Webb's data meticulously. They ran simulations, recalculated redshifts, and checked for lensing effects. Yet, even with those corrections, the results remained astonishingly consistent. These galaxies were real and they were ancient. They weren't tricks of light. They were there, staring back from the dawn of time. One of the most famous examples came from a patch of sky Webb observed called Sears 93316, a galaxy that appeared to exist just 235 million years after the Big Bang. When scientists first analyzed its light, they thought it might be an error. But further spectroscopic measurements confirmed it. This galaxy, massive and luminous, was among the oldest ever observed. It shouldn't have existed yet. If galaxies like this could form so quickly, It would mean that the universe was astonishingly efficient at building structure, far more so than current models predict. The first stars might have ignited almost immediately after the universe cooled. Entire generations of stars may have lived and died within just a few 100 million years. It paints a picture of a young universe that wasn't calm and dark, but vibrant, active, and alive with light. This finding also complicates our understanding of reionization, the period when the first stars and galaxies began to emit enough light to ionize hydrogen and make the universe transparent again. If galaxies formed earlier and faster, that means reionization must have happened sooner, reshaping our entire timeline of cosmic history. What's more, the galaxies Webb found weren't just massive, they were well structured. Some had disks, spiral-like formations, and even central bulges. The existence of such structure so early in cosmic history suggests that gravity and matter organized themselves with almost unnatural speed. The laws of physics seem to be in a hurry. To scientists, this is thrilling and terrifying at the same time. It's thrilling because new discoveries mean new frontiers, terrifying because it means something we've built our entire understanding on may not be entirely right. In science, progress often comes from contradiction. When the universe tells us something that doesn't fit our theories, it forces us to evolve those theories. Webb has become that force. Astrophysicists are now running simulations at unprecedented scales, trying to see if any combination of known physics could produce galaxies this massive so early. Some models show that it might be possible, but only if star formation was unusually efficient, perhaps 10 times more than expected. Others suggest that maybe these galaxies are filled with dark matter in ways we haven't yet imagined. And then there's the most provocative idea of all. Maybe we are not interpreting redshift the way we think we are. Redshift has been our main tool for measuring cosmic distances and ages. It's the key that unlocks the timeline of the universe. But what if there's more to it, some hidden factor, some property of light or space we don't yet understand? It's a question that makes even seasoned cosmologists pause. Still, science thrives on such mysteries. Every time we think we've reached the edge of understanding, the universe expands that edge. The James Webb Space Telescope has done exactly that, not just by showing us new sights, but by showing us where our knowledge ends. These 300 impossible galaxies are not anomalies. They are invitations to learn more deeply. The challenge now is to reconcile what we see with what we believe. Maybe that means adjusting our models of early star formation. Maybe it means rethinking dark matter. Perhaps it clumped earlier, triggering faster galaxy growth. Or maybe we need to revisit cosmic inflation, the theory that describes how the universe expanded faster than light in its first instant. If inflation was more complex than we imagined, it could have created dense regions that became galaxies sooner. Whatever the answer, one truth remains: the universe is not simple, and it never has been. It does not follow our expectations, it writes its own rules. And Webb has simply given us the eyes to see that. The implications of these discoveries ripple far beyond astronomy. They reach into philosophy, even into the way we think about existence itself. For if the universe formed faster than we thought, if complexity arose earlier, then perhaps the cosmos has always been predisposed toward creation, toward order, toward light. Maybe the emergence of structure, life, and consciousness was not an accident at all, but an inherent property of the universe, coded into its very fabric from the beginning. For centuries, we have looked at the stars and seen chaos slowly turning into order. But Webb's findings hint that order might have been there all along, that the universe's first act wasn't chaos, but harmony. It began not as a slow bloom, but as a sudden symphony. So yes, the discovery of 300 300 galaxies that shouldn't exist challenges modern cosmology. It shakes the equations that define our cosmic origins, but that's not a failure of science. It's its greatest success. Because science isn't about being right, it's about getting closer to truth. And truth, in the vastness of the universe, is always stranger, deeper, and more beautiful than we can imagine. The galaxy's web has found our silent teachers. Their light, stretched across billions of years, carries a message: you do not yet understand me. And that's exactly what drives humanity forward. We built Webb to see the unknown, and now that we have, it is humbling us, reminding us that the cosmos will always be one step ahead of our comprehension. And maybe that's the point. The more we learn, the more mysterious the universe becomes. Every discovery opens 10 new questions. Every solved equation reveals another unknown variable. The Webb telescope has not given us answers. It has given us deeper questions. Questions that will inspire generations of scientists, philosophers, and dreamers to look up and wonder, what else is out there that we haven't even imagined yet? In that sense, the challenge to modern cosmology isn't a crisis. It's a renaissance. It's the beginning of a new era of exploration. Just as Copernicus once displaced Earth from the center of the cosmos, Webb might be displacing our confidence in how we think the cosmos evolved. It's another turning point in the eternal story of human curiosity, where the universe shows us that every time we think we've reached the summit, it reveals another mountain beyond. Those 300 impossible galaxies, bright, ancient, and unyielding, are beacons from that next mountain. They're telling us that the story of creation is far richer than our current understanding allows. They are, in every sense, the universe's way of whispering, "You've only just begun to see." When astronomers talk about the speed of the universe, they are not referring to movement in the way we think of cars racing down a highway or planets orbiting a star. They are talking about something far more profound: the expansion of reality itself. Space isn't a backdrop where things move. It's the very fabric of existence, stretching, growing, and carrying everything with it. Since the moment of the Big Bang, this expansion has been at work, pushing galaxies away from each other, stretching light, and writing the universe's history in motion. But what James Webb has uncovered, those 300 galaxies that seem too old, too massive, and too bright for their time, suggests that this cosmic expansion, this flow of creation, may have moved at a pace we never expected. When Webb began its mission, scientists expected to see the universe in its adolescence, galaxies forming slowly, stars igniting in faint clusters, and the first signs of order emerging from chaos. Instead, what they found looked like a universe that had hit fast forward. Galaxies appeared only a few 100 million years after the Big Bang, fully formed, structured, and ancient in appearance. The question wasn't just how these galaxies existed, but how quickly they came into being. Everything seemed to have happened faster than physics should allow. The universe, according to our current understanding, has strict timelines. After the Big Bang, it took about 380,000 years for light to even travel freely. Before that, everything was an opaque plasma of particles. Then came the so-called cosmic dark ages, a long, silent period before the first stars formed. It wasn't until roughly 400 million years after the Big Bang that we believe the first galaxies began to take shape. But Webb's data showed galaxies forming as early as 250 million years after the beginning, galaxies that looked like they'd already lived through entire eras of growth. To put this in perspective, imagine watching the history of the universe compressed into a single year. On that scale, life on Earth would appear in December, and humans in the final seconds of December 31st. The galaxies Webb found would have appeared not in January, but barely a few days after midnight on January 1st, long before the universe was supposed to have the ingredients to make them. That means the processes of creation, star formation, element fusion, gravitational collapse must have been happening at astonishing speed. Stars formed, burned, exploded, and recycled their material into new generations of stars, all within a cosmic heartbeat. The universe was not a patient artist, it was a furious sculptor, churning out beauty from chaos with impossible velocity. This discovery raises a haunting question. Is our sense of time, our understanding of cosmic pace, somehow incomplete? Because if galaxies could form this quickly, something about the early universe, or our perception of it, must be different than we've imagined. Some scientists propose that the early universe may have been far denser than we realized, packed with matter that clumped together rapidly under gravity's pull. In such a dense environment, star formation could proceed explosively, lighting up space in a fraction of the time we expected. Others suggest that dark matter, that invisible scaffolding of the cosmos, played a more active role, accelerating the formation of galaxies by pulling regular matter together at a breakneck pace. But even with these theories, something still feels off. The galaxies Webb sees are not just massive, they are refined. They have structure, disks, central bulges, and defined edges, characteristics that normally take billions of years to form. To find such mature architecture so soon after the Big Bang is like walking into a kindergarten and finding philosophers discussing the meaning of life. It doesn't fit. This mystery of cosmic speed touches on something deeper, our relationship with time itself. We measure cosmic history in billions of years, but time is not uniform across the universe. Einstein showed us that time bends with gravity, that space and time are not separate, but one fabric, space-time capable of stretching, twisting, and flowing differently in different places. What if, in the early universe, time itself behaved differently? What if the physics that governed those first few 100 million years allowed for faster evolution, not just in the movement of galaxies, but in the flow of cosmic time? It's a radical idea, but Webb's discoveries force us to consider it. Because when you look at galaxies that shouldn't exist, you're not just questioning their speed, you're questioning the clock by which you measure them. Perhaps what we perceive as impossibly fast formation is simply a reflection of how the universe itself changed the tempo of time in its youth. Another possibility lies in the nature of cosmic inflation, that brief, almost unimaginable moment right after the Big Bang when the universe expanded faster than the speed of light. Inflation explains why the cosmos looks so uniform today and why galaxies are distributed the way they are. But if inflation didn't end the way we think, if it lingered, slowed unevenly, or fluctuated in intensity, it could have left behind regions where matter condensed faster than others. Those regions could be the birthplace of these ancient, massive galaxies. In that scenario, the universe didn't evolve evenly, it evolved in bursts, like a heart that beats in uneven but powerful rhythms. This might mean the early universe was not a calm, gradual unfolding, but a wild symphony of creation, bursts of star birth, waves of light sweeping through darkness, matter gathering in great swells of momentum. Webb, with its infrared eyes, has caught the echoes of that symphony. The galaxies it found are not errors in data. They are the remnants of that cosmic crescendo, proof that creation itself can happen with unimaginable speed when the conditions are right. And perhaps that's the real message, that speed, in the cosmic sense, is not just about movement, but transformation. The universe didn't rush, it bloomed. When you look at those early galaxies, glowing red from ancient light, what you are really seeing is the universe learning to create itself, learning how to turn energy into matter, matter into stars, and stars into worlds. That process might have been faster than we thought because creation, at its core, has always been an act of urgency. If you think about it, this pattern of accelerated creation echoes through everything. Stars are born in violent bursts of fusion. Life evolves in leaps. Even human progress happens in surges, centuries of quiet followed by explosions of innovation. The universe itself might follow the same principle: long silence, then sudden brilliance. Webb has simply shown us that the cosmos' first act of brilliance came sooner than anyone dared believe. But that revelation forces us to confront another question. If galaxies formed faster, did the universe also expand faster? The Hubble constant, which measures the rate of cosmic expansion, has been one of the great controversies in modern astronomy. Different measurements yield slightly different values, suggesting that our universe's rate of expansion is not fully understood. Now, Webb's discoveries might add another twist. Perhaps the early expansion wasn't just fast, it was uneven. Maybe certain regions of the cosmos expanded more rapidly, carrying matter outward in waves that condensed into galaxies. That could explain why Webb sees so many ancient, massive systems where there should have been only faint clouds. The universe might not be as uniform as we've believed. It could be a patchwork of different expansion rates, like a living organism growing at different speeds in different parts. And if that's true, it would mean that space itself has more complexity than we ever imagined, not just empty distance, but a dynamic, textured field capable of shaping reality at varying speeds. Webb might not just be showing us distant galaxies, it could be showing us the fingerprints of space itself, the signatures of how the universe grew from nothing into everything. To make sense of that, scientists are turning to models that go beyond classical cosmology, simulations that take into account exotic physics, quantum fields, and the chaotic dynamics of dark matter and dark energy. These models explore possibilities like early dark energy, a brief period when dark energy behaved differently, accelerating structure formation. It's speculative, but it could explain why the cosmos seemed to move in fast, forward mode. There's also the haunting possibility that our universe might not be alone, that what we're seeing are the remnants of interactions between our universe and another one. In the multiverse hypothesis, regions of space can inflate independently, creating bubble universes. If one of those bubbles brushed against ours in the early moments of creation, it could have triggered faster galaxy formation in certain areas. Webb's 300 impossible galaxies could be the cosmic fingerprints of that ancient encounter, a collision not of matter, but of realities. Whatever the answer, Webb has made one thing undeniable. The universe has always been faster, more dynamic, and more unpredictable than we ever dared to imagine. Its speed is not chaos, its purpose an ancient urgency to become, to expand, to create. Think about the light Webb captures, photons that have been traveling for over 13 billion years. Each one left its source when the universe was young and has been stretched, slowed, and redshifted by the expansion of space. Yet it still arrives, carrying a message across eternity, that even in a universe moving at unimaginable speeds, there is continuity. Motion doesn't destroy meaning, it carries it forward. In that sense, the mystery of cosmic speed is not just scientific, it's philosophical. It asks us to rethink what we mean by time, by growth, by becoming. The universe didn't wait for permission to create. It didn't proceed cautiously or slowly. It exploded into being, learned its own rules, and built galaxies in what we would call an instant. That relentless forward motion, that hunger to exist, might be the truest law of all. Maybe that's why, when we look into those distant galaxies, we feel something deeply human stir within us. Because we too are driven by that same urgency, the need to expand, to understand, to create. The cosmos rushes toward complexity, and so do we. Our lives are the local echoes of that ancient cosmic acceleration, the reflection of a universe that has never stopped racing toward meaning. Webb's discovery of 300 galaxies that shouldn't exist is not just a scientific puzzle, it's a mirror. It reminds us that existence itself is not a calm unfolding, it's a storm of becoming. Creation happens not slowly, but in pulses of brilliance. The universe doesn't crawl toward life, it sprints. It doesn't hesitate to evolve, it surges. And perhaps in that revelation there is a kind of comfort. Because if the cosmos itself could form beauty so quickly from nothing, then maybe everything, even chaos, even darkness, carries within it the seed of rapid transformation. Maybe creation doesn't need eternity, it just needs the right spark. So, when we speak of the mystery of cosmic speed, we are really speaking about the nature of existence itself, about the breathtaking velocity at which the universe learns to become aware of its own light. The galaxy's web has shown us are not anomalies. They are proof that creation was never slow, never hesitant. It was always urgent, always alive, always reaching forward, just as we do when we look up, searching for our beginnings among the stars. In the grand expanse of the cosmos, where silence stretches beyond comprehension, there lies a truth both humbling and beautiful, that the universe is far more mysterious, creative, and unpredictable than we could ever imagine. The James Webb Space Telescope, in its quest to explore the origins of everything, has not only revealed galaxies that challenge the foundations of science, but also something deeper, something profoundly human. It has shown us that even in the face of impossibility, existence finds a way. These 300 galaxies that shouldn't exist are more than just distant clusters of stars. They are cosmic symbols of defiance, reminders that the universe doesn't always play by our rules. It creates, it evolves, and it surprises. Think about what this truly means. For centuries, humanity has looked upward, trying to make sense of the endless night. We've mapped stars, calculated orbits, built theories, and drawn invisible lines to explain what we see. We've written equations that describe how galaxies are born, how stars ignite, and how the universe expands. But in doing so, we've also quietly believed something else, that we could eventually predict the universe, that the cosmos would fit neatly within the boundaries of human logic. And yet, time and again, the universe laughs softly in our direction, showing us that the moment we think we understand it, it reveals another layer of mystery deeper than before. The 300 galaxies Webb found shouldn't exist, not according to our current understanding. They formed too early, too bright, too large, and too complex in a universe that was supposed to be young, chaotic, and formless. It's as if the universe skipped ahead in its own story, like reading the opening chapter of a novel only to find a fully developed civilization thriving on page 2. These galaxies are the embodiment of cosmic rebellion, the universe's way of saying, I am more than what you think I am. But what if this discovery is not just about galaxies? What if it's about us, about the human spirit that dares to question, explore, and reach beyond the known? Every time a scientist peers into the blackness of space, they are not just searching for data, they are searching for meaning. And what James Webb has shown us is that meaning often hides beyond the boundaries of certainty. Science, after all, is not about having all the answers. It's about having the courage to face the questions that have none. When Webb's golden mirrors captured light that had traveled for over 13 billion years, it wasn't just observing history, it was observing persistence. Those photons had journeyed across time itself, surviving the expansion of space, the gravitational pull of unseen matter, and the vast emptiness that lies between galaxies. And when that light finally touched Webb's sensors, it whispered across eons, telling us a story no one expected to hear. You do not know the whole truth yet. That is the essence of discovery, not comfort, but wonder. The very act of being proven wrong by the cosmos is one of the greatest gifts of science. Because each time our understanding breaks, something deeper awakens within us, a childlike awe that reminds us we are still explorers, still learners, still part of something infinite. The existence of these galaxies forces us to confront a difficult realization that the universe might not be as slow and methodical as we thought. It might be wild, spontaneous, capable of leaps that defy all linear explanation. It might create in bursts, like an artist painting in a frenzy of inspiration rather than following a precise design. That is perhaps the most poetic truth of all, that creation itself, even on a cosmic scale, is art. And art has never obeyed reason. There's something deeply emotional about knowing that galaxies formed before they were supposed to. It mirrors our own human stories, people who succeed against the odds, who rise before they're ready, who build light in the darkness. In a way, these galaxies are like the dreamers among us, the ones who didn't wait for the right time. They are proof that beginnings can bloom anywhere, anytime, under any condition. Imagine standing on a distant planet within one of those galaxies, billions of years ago. The night sky would not yet be filled with countless stars, but with the early sparks of light piercing the cosmic fog. You would see the first clusters of stars forming, their energy shaping new worlds. In that moment, you would be witnessing creation itself, the universe learning to shine. And now, billions of years later, we are the observers of that same light, realizing that we are not just witnesses, but participants in this grand unfolding. Every discovery Webb makes is not just about understanding the past, it's about redefining the present. These galaxies push us to ask, if we were wrong about the beginning, what else might we be wrong about? Perhaps the limits we set in science, in life, in imagination are not as fixed as we think. Maybe impossibility is just another word for something we haven't yet understood. In the same way that galaxies formed faster than they should have, maybe humanity itself is capable of evolving faster than we believe. Every generation thinks it's reached the peak of understanding, yet each one is proven wrong by the next. The telescope's discovery is a cosmic reflection of that eternal pattern, growth through surprise, evolution through challenge. What Webb has truly shown us is that the universe is not a static textbook to be memorized, but a living, breathing mystery that grows with us. Its truths unfold at the pace of curiosity. Its beauty reveals itself only to those who dare to look deeper. The scientists studying these galaxies are rewriting what we thought we knew about the early cosmos, but in doing so, they are also rewriting what it means to know anything at all. There's a certain humility in realizing that our grandest theories are still just sketches on the surface of a cosmic ocean. We are like ancient sailors, navigating the stars with instruments that grow sharper with each discovery, but still limited by the horizon of our perception. Yet despite the uncertainty, we keep sailing, because it is in our nature to seek, and perhaps that is the most profound message of all. These galaxies, existing against all odds, mirror our own story as a species, small, fragile, yet endlessly curious. The same force that shaped stars and galaxies also lives within us, the drive to create, to explore, to push beyond boundaries. The universe does not simply exist around us, it exists through us. Our wonder gives it meaning, our curiosity gives it voice. So when we say these galaxies shouldn't exist, maybe what we really mean is that they shouldn't exist according to us. According to our rules, our models, our expectations, but the universe has never asked for our permission to be extraordinary. It has never bowed to our definitions of possible and impossible. It simply is vast, mysterious, and alive. In that sense, every discovery like this one is a message not written in words, but in light, a message from the universe to us saying, there is still more, keep going. It's a cosmic encouragement, a whisper of infinity urging us to never stop asking, never stop wondering. Because if the universe can birth galaxies that shouldn't exist, then perhaps within us too lies the power to create what the world says is impossible. Maybe that's the real connection between the stars and the human soul. Both are born from chaos, both fight to exist, and both shine brighter than they should. When future generations look back on this discovery, they won't just see data points or telescope readings. They'll see a moment when humanity looked deeper than ever before and realized once again that existence is bigger than imagination. That no matter how advanced our science becomes, the universe will always stay one step ahead, inviting us to chase its mysteries across time itself. So, as we stand beneath the night sky, staring into the same darkness Webb peers through, let us remember, the universe is not something to be conquered or solved. It is something to be in awe of, something that constantly reminds us that even in the face of the unknown, beauty endures. Wonder endures, life endures. The 300 galaxies that shouldn't exist are proof of that. Proof that impossibility is only a temporary illusion, one that dissolves under the light of discovery. Proof that creation, in all its infinite brilliance, will always find a way. And proof that as long as we keep looking up, the universe will keep whispering its secrets, one impossible miracle at a time.